Hello everyone, welcome to the video. This is Rahman. Today I'm going to touch the base with direct current or DC. This video I hope will be very helpful for all the engineers, especially the ones in the electrical streams who are starting their electrical circuit 1 or DC course. Nonetheless, anyone who has curiosity or interest in DC can enjoy this video as well. So let's get started. So at first, let us imagine we have a copper wire which is connected with the terminals of a battery, positive and negative. And when it's connected, the electron starts flowing towards the positive terminal, which has less potential. And for that, the current flow starts flowing towards the opposite direction and goes towards the negative terminal. So this very flow of current right there is called direct current. Now, if you take a DC battery, and a DC bulb, and we connect the bulb with the battery with a copper wire, and what happens is the electron starts flowing through the bulb towards the positive terminal, and when it reaches the positive terminal, the current starts flowing in the opposite direction through the bulb, and once the circuit is full, the bulb lights. So where do we get the DC from? The first obvious example is the battery itself. The battery can be charged from any means, and it could be from renewable source, which brings me to the next example, solar photovoltaic system, which gives us direct DC with the help of sun rays. And the third and the most obvious one is AC source. We convert AC to DC with the help of rectifiers or any other sort of converters. So since we are talking about DC, it is important that we are familiar with the symbols of DC. So I'm going to show you some basic symbols which are widely used in DC systems. The first thing we have is the resistance. It is denoted by the English letter R, and the unit is ohm, and the unit is denoted by the Greek letter omega. And then we have the current itself. As you can see on the left, you can see the current source, and on the right, the in-circuit current flow. It's denoted by the English letter I. The unit is ampere and is denoted by the English letter A. Then we have the voltage itself, and we have the voltage source on the left and the battery cell symbol on the right. And it's denoted by the English letter V, and the unit is volt, which is also denoted by V. Then we have the capacitance itself, and capacitance is denoted by English letter C, unit is farad, and denoted by English letter F. And the last thing which I want to show you is the inductance, is denoted by English letter L, unit is Henry, denoted by English letter H. Now let's take a look at a DC circuit. And we have a very simple circuit here. We have our voltage source, our resistance, and then we have the current flowing from leaving the positive terminal and reaching to the negative terminal. Now I want to also show you the Ohm's law, which is V is equal to IR. Obviously V is the voltage, I is the current, and R is the resistance. And V is proportional to the current I when R is the proportionality constant. So this formula seems very basic, and it is very important formula when it comes to electrical engineering. It's very important for the electrical engineers because you will be using it throughout your whole engineering in one way or another. Now let's talk about the application of DC. First, we have battery storage or backup storage. Also, we know it as a UPS. So it basically supplies as a backup power source. If like there's blackout or something, you can always use UPS for your backup power source. And then we have portable devices, electronic devices, such as smartphone, laptop, camera, anything portable electronics you can imagine has a DC system inbuilt, right? And then we have electric vehicles. Obviously, many of the electric vehicles they have been using induction motors, AC induction motors, for better performance. But the battery itself obviously is DC because they can't carry AC battery, right? So they use DC and have it converted for their motors. So now I want to talk about the main differences with DC and AC. I think it will give you a more clear idea what direct current is. So, first of all, obviously it has unipolarity, one polarity at a time, one direction, therefore constant wavelength, and there is no frequency at all. Unlike AC, it has alternating polarity, it's always changing, and that's why you have the sinusoid wavelength and also have the frequency. As you can see, like I wrote 50 hertz or 60 hertz because depending on your location, like I think in North America you have 60 hertz systems, and in the Asian parts you have 50 hertz. So it's just their standard. And then for DC, you have energy storage. You cannot store AC, right? Only is possible with DC because DC is a very one directional system, right? So it's much easier to capture it through capacitors in the battery or in whatever means, unlike AC, which has alternating direction. But then again, you have transformer in AC, and I cannot emphasize how important transformer is because if there wasn't transformer, electricity wouldn't be as cheap as it is, and we wouldn't be having electricity all around the globe right now. Transformer helps helps us really well to transfer the energy from one location to the other. It helps to step up or step down the power very easily, and we don't have transformer for DC because it doesn't have any induction unlike AC, and hence there you cannot transform DC like AC. So that's a very important key features of AC because we have transformer, and that's why we can transfer energy anywhere in the world. And then obviously electronics, all the electronics, all the portable devices, all the gadgets you can imagine. It's it's only possible because we have DC system, and that's why we can literally carry all the gadgets because it has inbuilt this system in it, and it's very easy to like having a compact setting. And then again, if you think about applications of AC, like other than the home appliances, you got heavy duty machines in the industry like three-phase motors. You can only operate those three-phase motors with AC system. You cannot use DC to operate those three-phase motors. Well, that's the end of the video. Thank you for watching. I hope I could give you an idea, a basic idea about what direct current is and what are its application and how we are using it in our daily lives. I hope I will see you in another video. Till then, stay safe, keep learning.